Find the coefficient of x to the power of 5 in the expansion of this expression. Now here we have a binomial power, but being multiplied by some other binomial. I'm going to go through two methods to do this. The first method, which I would say is the long method, is to work out the entire expansion of this one and then do the expansion. So let's do that first. So using this, we're going to do just looking at this bit to start with, we're going to do Pascal's triangle. So 1, 6, 15, 20, 15, 6, and 1. And now that we've got the Pascal's row, we'll do the next bit, which is start with the first power and do decreasing powers. So 2x to the power of 6, which I'm just going to write straight away as 64x to the 6. 2x to the power of 5 is 32x to the power of 5. To the power of 4 is going to be 16x to the power of 4. To the power of 3 will be 8x cubed, 4x squared, 2x, and 1. And then starting with minus 1 to the 0, which is just going to be 1. Then minus 1 to the 1, which is just going to be minus 1. Minus 1 squared, minus 1 cubed, minus 1 to the 4, minus 1 to the 5, and minus 1 to the 6. Now once we've worked out all of that and we multiply down, we're going to get that 2x minus 1 to the power of 6 is equal to 64x to the power of 6 minus 6 times 32 is 192x to the power of 5 plus 15 times 16 is 240 x to the 4. 20 times 8 is going to give me minus 160x cubed. 15 times 4 is plus 60x squared minus 12x plus 1. So that's the full expansion of this binomial. And then we need to multiply all of that by x plus 3. So doing that, we're going to multiply everything by x first. So then we're going to get 64x to the 6 minus 192, sorry, x to the 7 there, because the power went up by 1 because we multiplied by x to the 6 plus 240x to the 5 minus 160x to the 4 plus 60x to the 3 minus 12x squared plus x. And then we're going to multiply everything by 3. So on top of that, we also have plus multiplying this by 3. We're going to have 64 times by 3 is 192 x to the 6. And we've got the minus 192 times by 3 is minus 576 x to the 5. We've got the 240 times by 3 is plus 720 x to the 4. 160 times by 3 is 480, so sorry, minus, isn't it? Because minus 160, so minus 480 x cubed. 60 times to the 3 is plus 180 x squared. 12 times by 3 is going to be 36x, and then finally plus 3 on the end. So this is the whole expansion of x plus 3, 2x minus 1 to the 6. Now we're interested in the coefficient of x to the 5, which is going to be this bit here. So these two bits simplified. So our final answer is going to be the coefficient of x to the 5 is 240 minus 576, which is equal to minus 336. Now that is a perfectly valid way of doing this. You're obviously doing this whole expansion here, and that's quite time consuming. I can do it fairly quickly. You might not be quite as quick as me. So maybe there's a better way to do this. And the better way to do this, or to start thinking about the better way to do this, is to think about, well, how did we get those x to the 5s? Well, this x to the 5 here came from doing the 240x to the power of 4 multiplied by the x. And the minus 576x to the 5 came from doing the minus 192x to the 5 multiplied by the plus 3. So maybe we can use that to work out what we need to do. Well, we didn't need to do the whole expansion. All we needed was the bit that gave us the x to the power of 5. The x to the power of 5 bit was this one here. That's what gave us that term there. And we also needed the x to the power of 4. That was this one here. This gave us the x to the power of 4 term over here. Now, could we have worked out that those were the ones we needed? Well, yes, we could. If we needed x to the power of 5, and we're multiplying by x plus 3, the x has got to be multiplied by an x to the power of 4 to get to the x to the power of 5. So we then just need to do this row to work out the x to the power of 4 term. The 3 has to be multiplied by the x to the power of 5 part within this bracket. So we only need the x to the power of 5 part from within this bracket, which is this one here. So actually, the only things we need are those things in those boxes. We could have ignored everything that's not in the boxes or highlighted. We could have just done this bit here to get minus 192x to the 5. This bit here to get the 240x to the 4. And then when we multiplied those by the x and by the plus 3, we got what we needed to add together for the final answer. Now, that involves being able to think about what's going on without seeing the whole process. It's quite tricky. So if you need to rely on doing the whole expansion, that's absolutely fine. But that way might save you time if you can get through it, if you can get through that thought process without having to do everything.